Alright guys, so we'll try this again with sound this time. For the graphing equilibrium activity, I'm going to walk through the first one with you and show you how to approach these. I wanted you to be familiar with these graphs because these are things that may come up as diagrams for a multiple choice question or even as an FRQ. I am home with my child, so if you hear him, I apologize. But I'll try to walk you through this best I can. So we're going to work through this first graph together, and I'll give you a couple of hints for other things that are going to come up on some of the other graphs. For this one, experiment A says a chemist was studying the decomposition of methanol at a high temperature. She placed 1 mole of methanol in a 5-liter flask and allowed it to decompose for 30 minutes at that high temperature. After 20 minutes, the concentration of methanol had fallen to 0.050 molar, where it stayed for the rest of the experiment. So whenever it stays that way for the rest of the experiment, that equilibrium is reached. Here we do have the equation for methanol producing carbon dioxide and hydrogen. And it wants us to sketch a concentration versus time graph that would accurately reflect the data from the experiment above. It says show how concentration of all 3 species in the reaction would have changed over the 30-minute interval. So we're not only going to have to include methanol, but we're going to have to include the products as well. So it tells us we're graphing time versus concentration. And remember, concentration is a molarity. So we do have to make sure that our values are in molarity. The information it gave us with methanol is that initially we had a 1 mole of methanol in a 5-liter container. So finding the molarity, we do 1 mole over 5 liters. That's about a 0.20 molar methanol. So that's going to be our starting point. And I would try to make this somewhere in the middle of your graph, just based off of our reaction. Those coefficients are going to come into play. So we have 1 of the methanol and carbon monoxide, but we have 2 hydrogen. So that essentially means that hydrogen is going to increase twice as much as the methanol will decrease. But let's look at methanol first. If we spread out our scale, so if I start at 0, I want the 0.2 to be somewhere in the middle of my graph. Sorry. So we're going to go up by 0.05. So then that would be 0.10, 0.15, 0.20, 0.25, 0.30. And this does need to span at least 30 seconds. So I'm going to make each line 5 seconds. And that would go a little over 30 seconds, including everything. So methanol, I'm going to draw in blue. So we can put a little key out to the side if needed. So we said initially we had 0.20 moles of methanol. And it tells us after 20 minutes, the concentration is now 0.05, which would be here. And we said it leveled off the rest of the time. So it would be kind of straight line. Sorry, I can't draw a straight line after the fact. And this would decrease to become that straight line. So that would represent our line for methanol. Let's do carbon dioxide. Notice that carbon dioxide is a 1-to-1 ratio compared to methanol. And products should increase because we didn't start with any of them. So it should initially be at 0. And since they're a 1-to-1 ratio, that means that the carbon monoxide will increase just as much as the methanol decreased. So since methanol went down by 0.15 in that 20 minutes, that means that carbon monoxide will go up by 0.15 in that 20 minutes and then level off because it reached equilibrium. So this would curve like that. So yellow is representing our carbon monoxide. And then we have hydrogen. So hydrogen is a 2-to-1 ratio when we're looking at the other substances. So that means that since it's a product, is increasing, and it is increasing twice as much as the other substances. So since the carbon monoxide went up by 0.15, that means the hydrogen is going to go up by 0.15 times 2, so 0.30. So hydrogen would also start at 0, but at 20 minutes, it's going to go up to 0.30 and then level off. So this, because it has a higher coefficient, will have more of a slope and increase more overall. So that is our graph representing the 3 substances. Whenever it wants us to write the equilibrium expression, remember the expression is going to be the formula. So you're going to be writing the formula with products over reactants, but you need to use the actual substances in the equation. And then number 3 wants us, based on the information at the graph above, calculate Kc. So remember, K is at equilibrium. So we're going to use the values at that 20-minute mark because that is when equilibrium is reached. And you're going to use that to calculate the value. Looking at some of the other graphs, just some things to think of. Experiment B's graph is going to be very similar. Do be conscious that it gives us moles in a 5-liter flask. So you do need to find molarity. It asks you to sketch the other values. If you don't have different colors, you can use like shapes to represent the different substances. Just make sure to include a key there. That will help you out. It wants you to write the Kc expression. Same thing like we did on the last one. This question 4 can trip people up. It wants to know the effect on K if there's a catalyst. So I want you to think about what a catalyst does, and would that affect the amounts that are produced. Whenever you go on to experiment C, it gives you another substance, and yet again we have moles and we have liters, so you would need to find molarity, or in this case we are dealing with pressure. So it gives you moles, volume, temperature. So in order to find pressure, you can use the ideal gas law. So that will help you out a little bit. And then it tells us once equilibrium is reached, 80% of the substance is decomposed. That means that only 20% of the substance is remaining. So be careful when you're finding that one out. And it has you sketch the graph. And then it wants the expression for Kp and to calculate Kp. So we talked about this on Friday. Remember, this is the same setup for K, but Kp expressions use parentheses and the pressure of whatever the substances are. So do make note that whenever you're writing that Kp expression, it should have parentheses, and it has to have P designating that pressure of whatever that particular substance is. And then whenever you get to experiment D, this is very similar to some of the others. Yet again, it brings up the factor of what would happen if there is a catalyst. So remember, think about what a catalyst does and would that change the amount produced. Hopefully this helps you get started on these. I don't know if we will be in class tomorrow. Tentatively, this is going to be due on Thursday, but I do want to give you a chance when we are back together if you have any questions. So that deadline may change, or it may be things where I maybe do not deduct points for, but we discuss these. So make sure you're paying attention to announcements, stay home if possible, and be safe. I'll see you soon.